Chen ma'am? Good afternoon to all of you for finding time and visiting today to our second day webinar. My name is Randi Maulan Nasir, and in this session, once again, I will be your moderator during this webinar with my co-moderator, Mrs. Desti. Okay, Mrs. Zumroh, Desti, and Grainy. Before we started, I will ask you one question to check if you can see and hear me well. Just give me thumbs up. Okay, great. Now, I would like to give a honorable mention to our special attendees. First to Mr. Asep Handaya as Head of Chemical Engineering Department of University of Indonesia. The second is Mr. Nuramzan Iftari, the Senior Analyst Information Management, PT Perusahaan Gas Negara. Mr. Ganjar Ali Setiawan, Manager Infrastructure and Manager Optimization, PT Pertamina Gas. Mr. Bahman Tauhidi, Professor, Managing Director, Heriot Watt University, Hydrofac Ltd. Mr. Sutrasno, Mr. Andi Nur Saman, and last not least, Mr. Adrian Nengkoda.
Welcome to second day of ICGMET 2020. ICG MET 2020 is the first international conference on gas management, engineering, and technology. Like before, we would like to inform again that the theme of the webinar is natural gas outlook and market challenges. Mr. Randy would like to present the webinar ethic so you can understand the webinar terms and conditions to make our webinar more pleasant.
Now, I will inform you all the webinar's ethic. The first, participants should fill attendance link provided in the chat box. No recording allowed, organizer only. Question or comments can be write down via chat box and preferably in English question with question format, name underscore company slash institution underscore question. Speaker will answer the question for the attendance after presentation completed. Because of this tight schedule, organizer will select the best question to be answered by the speakers. Now, my co-moderator will inform you all the speakers today and their sub-team.
Here is the rundown for today's webinar, including the list of speakers and their sub-themes. There are, first, integrating big data into one platform to improve reliability and maintenance program for business goes downstream will be presented by Mr. Nur Amzan Iftari. Second, case study and best practice in natural gas metering system will be presented by Mr. Ganjar Ali Setiawan. And the third, best practice in hydrate management will be presented by Mr. Bahman Tohibi.
Once again, let me explain to you by how you can talk us during this webinar. If you have any question during this presentation, just save it and we will have a Q&A session after the speaker finish their presentation.
Moving on to the first presentation by Mr. Nur Amzan Iftari. Mr. Nur Amzan Iftari worked at PT Perusahaan Gas Negara as Senior Engineer Reliability Management since 2019. Once again, if you have any question, just send it in the chat box and later we will select the best question. Now, let's begin with Mr. Nur Amzan Iftari presentation. Please welcome to Mr. Nur Amzan Iftari to give your presentation now.
Good morning, ladies and gentlemen. My name is Nur Amzan, and I'm work at PT PGN Tbk as a senior analyst information management. Today, I'd like to share to you about my presentation about integrating big data into one platform to improve reliability and maintenance for business gas downstream. Before I start to introduce to you about my overall section today, I'd like to share to you about my biography. I worked at PT Pertamina Gas since 2008 until 2020. And from January 2020 until November, worked as a senior engineer reliability management, and at November 2020, worked as senior analyst information management. I have several certifications such as bachelor degree in electrical engineering, master degree in operational production management, and currently I'm undertaking master degree as a student in gas management at University Indonesia. And I have several other certifications such as Certified Maintenance and Reliability Professional from SIMRP, Certified Reliability Leader from AMP. So there is a fifth section. Yeah, the first one, company provide. So PT Perusahaan Gas Negara is the leading natural gas distribution and transportation player in Indonesia. The gas continues to strengthen its position in the market by gradually transforming into integrated energy solution company, encouraging the use of natural gas. So PTPGN have several business at an upstreams here. PTPGN have Saka Energy Indonesia. In the midstreams, there are several subsidiary company such as PLI, Central Regas, TGI, KGG, Portagas, and PAG. In the downstreams, there are customer that we deliver the gas, such as industrial sectors, commercial sectors, customer, hotel and restaurant, power plant, commercial customer, household customer, and also there are MRU. And for customer not connected to the pipeline, we have a subsidiary, PT Gagas Energy, that have a solution called GasLink, for channeling natural gas to locations that are not connected to the gas pipeline. So the vision of PTPGN is to be the world leading national gas company for a sustainable future and national energy sovereignty. And our mission is to provide and develop infrastructure to utilize gas as energy, creating added value for stakeholders and employees, carry out the principle of professional responsibility, sustainable management of the company, and organize the business to support gas utilization, sustainable business management. And PGN in here, as a parent and the child or subsidiary, such as PT Saka Energy Indonesia for oil and gas upstream, PT PLI, PGN LNG Indonesia for LNG processing, transportation, storage, and trading, PT Gas Solution that focus and deliver operation, maintenance, engineering, trading, and EPC of oil and natural gas, PT Gas Telecommunications Nusantara for to provide services such as technology, communication, and information technology, and PT Transportasi Gas Indonesia, PT Pertamina Gas as a transportation natural gas, PT PGN Mas for deliver manpower, provider service and facility management, PT Gagas Energy to provide gas link, to connect from source to the customers that not connected to the pipeline, and PT Nusantara Gas for natural gas trading through LNG regasification facility. Section 2, SWOT analysis for gas business downstream. So, the strength of business gas downstream in Indonesia, there is an integrated natural gas infrastructures now, currently. Natural gas quality, which is good and environmentally friendly. And then, good company performance and customer confidence level. There, from customer service begins when the prospect wants to get information about subscribing the gas. So there is a synergy of gas subholding in Indonesia has been formed, and natural gas infrastructure capacity support additional natural gas distribution. And the weakness is several gas infrastructure approach design life dependence on procedure, who explore, So business gas downstream nowadays dependence on producers of gas. The purchase price of gas from producer following world market trends at the time of tender is regulated by the regulator. And the demand for the application of cost efficiency. Nowadays in COVID-19 also, several gas company in the business downstream have to apply the cost efficiency program. The opportunity, the demand of natural gas is very high for both the power and industrial sectors nowadays for the gas. Abundant natural gas reserve in Indonesia, the price of net alternative fuel are still high compared to natural gas, except for the coal. Coal is more cheaper. The drastic increase in the population of Indonesia and technology development, and there is a gas conversion technology available in the market today. And the trade, price regulation from regulator. This is the first trade in the applied business gas in the downstream. There's also the priority of allocating gas supply for oil, fertilizer, electricity, rubber processing, and plastic industry in the fifth priority. Very large investment costs to build a pipeline and other infrastructures. And there is natural gas subsidy product nowadays, such as diesel and coal, mostly used by industrial and power generation customer. Subsequently, LPG, kerosene, and firewood also mostly used by household and small-scale customer. So this is the trade for the how to increase the gas delivery and consumption to the market. Tight competition also, the trade in the business gas downstream with the trader. And how about the TOS analysis? We should have such an action about this. So the TOS analysis, weakness versus the trade, the initiative is increase additional gas supply by developing gas conversion technology. Increase gas supply allocation for industrial sector by innovating gas derivative products. This is the two initiative that we have discussed in our student assignment. And the strength versus rate increase alignment of the need of producer and customer in order to be faster in determining the allocation of gas supply, improve performance and customer confidence to make better use of natural gas. So we have a weakness and we have an opportunity. What is the initiative? Fulfilling the high demand for natural gas by innovating gas transportation mode, such as there's a container ships, truck and rails nowadays. So we have other alternative gas transportation mode. And if there is a potential gas well, build a new gas pipeline network. And high population growth nowadays. So prioritize fulfillment of natural gas in this location. Strength versus opportunities. How the initiative? Increase the reliability of gas infrastructures to meet the demand and potential for new gas resources, because there's a lot of demand and also there is a potential for these gas sources for the existing facility to support the incoming of the gas supply. We have to increase durability. Yeah. Reducing investment costs by implementing an integrated gas infrastructure. Yeah. So how we could increase the downstream gas business income in Indonesia. There is a 7 ideas that our group have discussed. Yeah, the first one, develop of alternative product conversion technology into gas. Yeah, to mitigate the dependency of the gas producers. The second, gas derivative product and efficient and mode of transportation. The third, digitizing the determination and priority of gas supply allocation, increase the performance development in consumer confidence, build a pipeline network toward the exploration potential of gas well, digitizing and servability, improving gas infrastructure, and integration of gas subholding infrastructure. So in my presentation today, I'd like to share to you about ideas to increase the downstream gas business income, which is digitizing asset reliability and improving gas infrastructure. So the third, integrating big data of reliability and maintenance. Yeah. So big data is a field that trades a large amount of data from various sources that traditional data processing systems are incapable to deal with. So commonly, big data analyzed by BI tools, business intelligence tools, yeah, that could gather the data from various data sources to understand the past business performance in order to improve future performance to make it easier in making the right decision. So CMMS in here, there's a big data in CMMS. So there's a preparation of data, what table that we have to get the data in CMMS itself. So using Informatica to extract, transform, and load the data from probably use a SAP or Oracle, or probably there is another CMMS that use a database SQL Server or other database, maybe Postgre or MySQL and so on. Get the key data, main key data to the data warehouse. Our initiative use Postgre, and the visualization use Tableau and Power BI. I will introduce to you about the Tableau and Power itself. And for business user, there's a web programming. There is a feature to manage the group that could be displayed by filter the dashboard according to the responsibility, and the trend and bar chart and the target itself. So there's a lot of analytic business intelligence platform nowadays in the market. So for IBM or Maximo, yeah, in the Gartner survey, yeah, there's a website in here. I took the pictures. For the Maximo, the complete data vision is lower, and ability to execute is also lower. For SAP and Oracle, complete data business is higher because there is an integrated model to other function available, but the ability to execute is lower. And nowadays, there's a Tableau and Power BI that's a commonly delivered business lead self-service analytics. So we could customize. There's a lot of feature to generate the dashboard like this and this. And this is as a second wave of a modern platform that disrupt IT lead enterprise repository tools. Yeah, nowadays. So What is CMMS? CMMS is computerized maintenance management system that tracks all maintenance activities, maintenance work order, PM schedule, PM master, monthly pass, work plan, and asset stories, and is usually is integrated with the support systems, like such as inventory, purchasing, accounting, manufacturing, and so on. So this is the Oracle Business Suite. There is a modules, procurement, finance and asset management, inventory, and so on. SIP also have an integrated module, plant maintenance for CMMS. So the SIP also have a HR module, quality management, material management, and so on. So CMMS itself in Oracle called Oracle EAM, in SAP is SAP plant maintenance. Consists of work order management, how we manage work order, how we manage the inventory, the checklist report, and the reports of maintenance performance, breakdowns, and preventive, the classification of the work order type to see the ratio of a breakdown and preventive maintenance. So CMS system infrastructure, the foundation is we have to gather the assets, facility, equipment, part, instrument, and utilities. And if we have a complete asset registered in the database of the CMMS, we could execute the transactions such as generate work order and so on, do the scheduling and do the analytic, of the data that entered into the CMMS to generate report, dashboard, automated report. And what is the goal of the CMMS? To see overall availability of our assets, the schedule compliance of the work order between plan and actual work, and the cost of maintenance. This is a simple work of CMMS. There's a 6 phase of CMMS stage. From initiation, create work request. Usually from the in the field, there is such an anomaly. Probably there is an anomaly in the gas turbine compressor. There is a high temperature in the combustion facility, combustion unit, and the operator create the work request and coordinate with the supervisor, and if the supervisor approve, and then go to the planner, to create work order, and if the and then go to the scheduling to determine the resource availability, load leveling, and do the execution and complete and failure analysis. So this is the corrective maintenance phase. In the breakdown or emergency, commonly create work request, and this step is parallel with the execution because the priority is high for breakdown or emergency. And for predictive, usually in the first day of the year, enter the PM schedules, the execution date, and maintenance frequency. And then after the time is travel, and this is the date where the execution have to be performed. But usually to the direction to the execution is in the dash, because probably in this line there is some emergency or breakdown happen, so we have to reschedule our execution date. So reschedule and do the execution according to confirmed resource determined date, and do the completion and the stage. And then commonly this 6 phase enter to the SIP or Oracle e-business suites, and the performance evaluation analyzed by Power BI or Tableau. So the output of the completion of failure analysis, do the improvement of planning. So this is the detailed one for the workflow of CMMS modified in this manual. So there is a 3 group of maintenance, and a breakdown of emergency like this. There is a leak of the pipe, so probably breakdown or emergency maintenance. Create work order parallel with the execution. And for the new work from PM or CBM, corrective maintenance, divert maintenance, and reliability maintenance, usually create work request and then approve. There is a risk matrix in this phase. And then do the planning, create work order, determine the scope of work, estimate schedule, owner estimates, internal labor, PR for non-stock material, PR for external labor, reserve for stock material. And in the scheduling process, uh, analyze the resource availability, load leveling, and do the work execution, commonly print work order, perform job, material issue, and fill the checklist. Yeah. And for pre-planned work, execute the preventive maintenance, predictive maintenance. Yeah. There is a scheduling process and execution work that should be done. Okay. Forecast work order, and then sign work order. Failure analysis, actual research and actual schedules, and the maintenance activity story. We have a schedule compliant performance, mean time between failure availability, and MTTR. And cost of maintenance. So there is available data such as asset risk, asset performance, and asset cost in the CMMS itself. And do the improvement of the planning process for the history of a asset. Yeah. This is the difference between the workflow CMMS Oracle AM and SAP PM. The main process is the same, but the term in the master data is different. And the term of the closing is also different like this. Yeah. In master data, the technician that execute in the field called owning department in SAP work centers. And for the standard job plan, Oracle called maintenance route, SAP called maintenance task list. Yeah. For the payment process, the closing is in SAP service acceptance, in Oracle PO receipts. Yeah. And for the failure analysis in Oracle, in the SAP technical feedback for notification. Yeah. Case study big data visualization from CMS. I will show you the dashboard. So this is a dashboard, use Power BI. Yeah. So we could analyze the total equipment number, yeah, PM percentage, how the ratio of a corrective, preventive, and any emergency work ratio, yeah, and also the reliability growth, and the failure modes, and so on, yeah. So the formula is like this: PM percentage, emergency work ratio, reliability growth, yeah. So if we select the equipment, the bar chart of the failure mode and reliability growth is changing, and also for the determined date, PM percentage and emergency changing very fast, yeah. So we could analyze for planning process. Yeah? And how about the tableau? The tableau is like this, yeah. The total asset number, asset criticality, yeah. The dashboard of CMMS itself, emergency work ratio, reliability growth, and failure mode trend, yeah. So we could have the information of the most failure mode that happened in the plan. So the asset number using SDV. So we have SDV in the plan, external leakage here, reliability growth, and the overall PM percentage filtered by that we could look at it. Yeah. So in both of the dashboard, reliability growth analysis use this exponential formula, and the in the dashboard we have to filter the type of work order, preventive maintenance, and status of work order itself. Yeah, and enter the formula in the Tableau or Power BI, and this formula is executed automatically. Yeah, to view display this dashboard fast. Yeah. So how to succeed in CMS implementation? Yeah, we have to know the way it failed. Yeah. The first one, lack of management commitment. Yeah, if management not commit, not there is no campaign. Yeah, no indicator of performance that include the CMMS in the responsibility of the persons or employee. Then the CMMS could not demonstrate the true reflection of output. Yeah, wrong CMMS selection. Yeah. There's a lot of the market fancy system available, but realizing their actual requirement is lower and end up in incurring under cost. And then this is several company experience this field, yeah, because garbage in, garbage out, yeah. The data quality of CMS requirement is not met, so the analyze of the decision is not good enough. Broken or completed maintenance process. This is also a lot several company experiencing this, because CMMS is a tool. Yeah. So if the rider use the CMS good, then the tool is also good delivered the good maintenance practice that have a true reflection, the same reflection that happened in the plant. Broken or completed maintenance process. Lack of proper training and vendor support. This is also happen. So because this is a computerized maintenance, so we have to train the inputter, yeah, to input the data in the CMS itself. And also there is a bug, and there is a upgrading in the software itself, and we have to cooperate with the vendor to support if there is a bug, and improve in the configuration. Lack of periodic audit and review. This is also happen. So we have to engage the inputter with audit and review. Yeah. So the improvement in the CMMS application would be better. So we have know the way it fell. We should create a roadmap, because this is the CMMS application should should think as a journey. Yeah, not a single journey, but as a long journey. Yeah. So the first step, we have to create a climate for change. Yeah, because probably there is some old application and there's a new one. So we have to gather management commitment to this new software, gather CMS champion. And then why we have to do this? Yeah, gather CMS and get management commitment, because employee don't know why they are doing what they are asked to do. So after we create the climate for change, we have to engage the whole organization. All the person have to know the input, process, and output of the CMMS itself. So there's a lot of employee in the organization know the benefit. So we have to establish our review strategy, procedure, and user manual, conduct training and replacement regularly. And the third, implement and sustain the change. Implement internal audit and external audit, review, evaluate that, and evaluate data quality and ease of use. Ease of use, because probably there is an upgrading for our vendor support. We have to cooperate with that. So probably the CMMS application we have applied, there is a ease of use, the upgrading one. So if we apply the new configuration, we have to do the training again, replacement regularly, and establish the strategy. Yeah. So the application of CMMS from unfriendly operation to the user friendly. Yeah. So if we have execute this phase, yeah, you should have here the wake up call. The employee in the organization will wake up and realize the benefit of CMMS, why we have to input the work request, approve work request, and planning and schedule the work order, and do the completion and failure analysis input. Yeah, because CMMS usually input by the person, maintenance person. Yeah, that usually have a lot of FTT, but the person itself should enter the data, yeah, properly in the CMMS application. Probably in the pipeline guy, the internet connection is not available, yeah. So we have to conduct training, refreshments regularly, and know the benefit and engage more properly. And so we also have to gather the champion that not waiting for things to happen and try to go out and make them happen. Probably there is a change of organization, but the flow, the initiative of this CMMS, well, not disrupt by other behavior of the culture of the changings. Yeah. So we have to gather the CMS champion with a good initiative to make our CMMS and reliability maintenance data, yeah, in the business gas downstreams better and optimize. Yeah. So this is the end of my presentation. Thank you very much for pay attention in my presentation today. I hope you are in good health, and thank you very much. Good morning, ladies and gentlemen. My Good morning, ladies and gentlemen. My
Thank you very much, Mr. Nur Amzan Iftari, for an enlightening and insightful presentation. Now, shall we begin to the Q&A session to keep this on schedule? For the Q&A session, we have selected the best question, and now I will tell you the first question. The first question is, how is utilization of machine learning software to analyze big data, such as neural network? Have it been utilized effectively so far? How is the presenter experience? Please, Mr. Nur Amzan Iftari, to answer this question.
Okay, thank you very much, Mr. Jumra, for share the question from the participants. For the machine learning, I like to share some my appendix presentation. Yeah. So before I start to answer the question, I like to share to you about what is the relationship between business intelligence and artificial intelligence. So artificial intelligence here. So if you would like to, sorry, artificial in here in machine learning in here. So machine learning have some benefit or a function to recognize a speech, yeah, a speech like a voice, and recognize such an image. Yeah. Machine learning is likely to utilize at some, if you search Google or Instagrams, and then the search is mainly that you frequently search for the key. Yeah? So in machine learning, like Google search and Instagram search and so on, he analyze the frequently we search for the key to and know our behavior. So the machine could share the behavior of end user itself. Yeah. So machine learning in here, and it will create real-time dashboard like here. Yeah. So my presentation in here. The analysis, the data of maintenance. Yeah. Business case study in here. So you see that there is a reporting with visual and creating dashboard. It represents the failure of the maintenance and the activity of maintenance itself, and create the dashboard from CMMS. So the maintenance will enter the work request, work order, and the failure analysis itself, and then create dashboard automatically by the Oracle or SAP. Yeah, but it is only show you the present, and the analytical function have to be some person to see in the dashboard, and then create such an analyze. But to create such an analyze, we could use the machine learning. Yeah? Maybe what time the engine will break down, and then the overall performance of schedule compliance, yeah, of a maintenance activity would be done by machine. Yeah. So machine learning is it's up to the company. Yeah. Is this benefit or not? Especially for the maintenance that I share you, maintenance process. Is it benefit to use machine learning? So go ahead. Yeah. But it's benefit to your business process to use machine learning. Try to use it, because in the maintenance, yeah, probably if we use a drone or robotic, and then the result of the drone or robotic, especially to see the thickness for analyze the risk-based inspection. So you use a robot and then use the machine learning, analyze the image of the thickness of the pipeline, the overall surface, if there is an anomaly, and machine learning will show, will create the analysis about maybe probably 3 years from now or 1 year from now, the pipe should be replaced. Yeah, and the speech, yeah, the voice, maybe the utilization, maybe if there is a noise, probably there is an alarm, yeah, and create some decision to management to repair the equipment. Yeah, so machine learning here. So you should have such a data and analysis, business intelligence first, and there is a real-time dashboard, probably the speech or image. Then the machine learning could analyze this and create the decision for strategic or technical decision. So I hope it's answered the question. And the utilization itself, well, it depends of the company. The company want to use machine learning or artificial intelligence to increase the income itself. So if it's benefit, then use it. If not, well, maybe we have to create a roadmap, step by step. The first one, implement the business intelligence, and then implement the data science, data analytic, machine learning, and artificial intelligence. So I hope that answered the question. So it depends on the company journey to implement the digitalization, because digitalization will increase the OPEX. Yeah, is it good or not to increase the profit? Yeah. I have the answer question. Thank you.
Okay, thank you, Mr. Nur Amzan. Now we shall continue to the second question. That is, why PGN or Pertagas metering record different result with my company records or report per day? Please, Mr. Nur Amzan, Iftari to answer this question.
Okay. This is about custody transfer, yeah, for the metering. So for the metering, there is a maintenance. The first one, we have to do the zero check, loop test, and the validation. And in the validation activities, we have to cross-check the AGA 10 or 3. It depends of the method that use, which turbine method probably, ultrasonic or probably orifice methods, and then compared with the calculation in the flow computer itself, and it's the validation or the percentage of the differences between the AGA calculation and the flow that run in the meter itself is decreased than 1%. Then it should well, it should be a correct measurement. So it have to see the result. Probably maybe there is some sensor or a gas chromatograph or flow computer itself. It have to see if the data is correct or not. Yeah, if the data is correct and the analysis by the application is correct too, then it should give the correct result, not garbage in, garbage out. So the data entered to the good quality. So the output could be good also, the quality of the result of the metering itself. Well, I hope that answered the question. I don't know the correct one, because that depends, yeah, about the data, the input data, the process, and the output is also. If the data is good, then the output is good also. It depends of the quality of the sensors, pressure transmitter, differential pressure transmitter, and so on. If it is correct, maintenance is correct, then the result is correct too. I have the answered question. Thank you.
Okay, Mr. Nur Amzan. The next question is, from the big data concept for gas company, how how PGN collaborate the data to compete in domestic market and the global. Is there any analytical apps or system to forecasting supply demand in Indonesia? Please,
Okay.
Mr. Nurrahman, to answer this question.
Okay, thank you very much. So, there's a lot of analytic and business platform nowadays, yeah, for forecasting using Tableau or Power BI. There is a feature to forecasting. There is a probability 90%, 99%. From CRMS, we could forecast the count of work order, the maintenance cost, and after 5 years, there is a result of the predictive prediction of the maintenance cost that happen in 1 year upfront. Yeah, that's a feature itself. So it's depend. Do you use if you see my slide, Tableau and Power BI is you could self customize on yourself, yeah. But in other software like Bentley Asset Performance Management or Meridians that could display the same result, but we have it's depend on the vendor, yeah. Not we not have some access or a feature that we could customize. So it's depend on the software, but using Tableau or Power BI, there is a feature to forecast, yeah, which is the data is a sales, supply and demand, or maintenance cost. There's a forecasting in there. But I have experience if the data is not, there is a hole in there, maybe January, there is data. February, there is no data. March, there is data, and so on. If there is a hole in the time series, then the forecasting will give incorrect result. I hope that answer question. Thank you.
Okay, Mr. Amzan. The next question is how the security of the data in PGN to secure confidential information can the government of or the holding company get access?
Okay. Okay. Thank you very much for the security. Yeah. We have two systems. The first one using our internal network. The second one external. Sorry, publish. Yeah. So if there is an app, yeah, that we trial and error and then do the cleansing, and so in the our internal network is could useful, yeah, to be utilized. And then well, for if it's used the internal network, we have to use the application such as a virtual private network and go to the internal network of our company. But there is a solution to not using a virtual private network. But in our policy, the application, the web, we have to enter or do the pen test. Yeah. So the activity is pen test. If the pen test is correct, the not the probability that the data could get from the outside is lower. Then the pen test is good, and then we could publish the app. Yeah. So our policy, we should pen test first, and then the application could publish, not being accessed in our internal network. Yeah. I hope that answer question. Thank you.
Okay. For the next question is, has Pertagas developed big data not only maintenance, but integrated starting from planning, budgeting, supply chain, and etc.? Which companies use this big data? What is the main problem?
Okay. Big data is a tools. Yeah. Big data is a tools. So using Tableau or Power BI, yeah, we could get the data and then enter the logic, the formula. For example, the formula is we want to analyze net profit, yeah, net profit, and then there is a data like a cost or revenue. Enter the formula in the Tableau or Power BI, and the net profit will show the dashboard itself. So it's very useful to use Tableau or Power BI because we could customize with our own self. So it depends on the company, yeah, itself. The company will want to use the available software in the market. So there's a vendor support, and then if there is a trouble of the configuration, we call the vendor, or we could customize with the software that has a feature to customize itself. So in PGN, there is some we have a Tableau that could use by all the function. So we could customize and you and create the dashboard. In Pertagas, we adopt from Pertamina. There is a Power BI, the business intelligence tools. So it could use if there is a data, and then use the Power BI and create the dashboard. So it depends on the company journey, and we are going to utilize the business intelligence tools, and I hope we could make useful of the software itself, yeah, to make fast our to in creating our decision. Thank you. I hope that answered your question.
Okay, for the next question, you mentioned several ideas for increasing downstream gas business income in Indonesia. How about the other idea? In your opinion, why it can be done or ineffective?
So there is a lot of ideas, yeah. Maybe there is more ideas in the TOS analysis. Well, we have discussed, and there is a 7 ideas we analyzed by the journal or the paper or the internet. Well, it depends in our brainstorming, yeah. If our brainstorming that result that those ideas, probably maybe there's an effective one. If there is another, maybe an input, then our brainstorming, we could give the good result. So, well, in our team, that's the best ideas, yeah, to increase the business gas downstream in Indonesia.
Read more about the effect.
And sorry, so the effect of this, well, it could increase the income, yeah, because we have searched the papers and the journal and the web itself. The ideas could increase. For example, yeah, for example, um, innovative of the gas transportation mode, yeah, such as LNG use ISO tanks to connect from a supply to a customer that not connected to pipeline. If it's running, and then it could increase the income. It is first one. And the second, now currently the price is regulated by the government, but in this industry, not. Yeah. If in yesterday, Mr. Putra Arjuna showed that if you want to increase our income, then we should focus in industry, not the other company that regulated by the government. So the effect will be the income for the company will increase. Yeah, if 7 ideas utilized properly. Thank you. I hope that answered the question. Yeah, I'm sorry.
Okay, for
Not
the
correct.
next question is, could you please elaborate more about the effect of the application this business intelligence to your business objective? For example, increasing revenue of business gas downstream, whether is it worth it will all the expenditure invested or not? Thank you.
Okay, business intelligence is a tools, yeah, for maintenance, yeah. If you see in the dashboard, we could see the PM percentage versus corrective maintenance. So if the correct maintenance or breakdown we could minimize, preventive maintenance could higher, then the breakdown of the equipment itself could be reduced. Yeah. If the breakdown will reduce and the OPEX will reduce also, revenue is the same, cost is minimized, and the profit will increase. Yeah. So the maintenance is a long-term journey. Yeah. If maybe 3 years or 5 years, yeah, if you have a college in industrial technique about the reliability emission, reliability should analyze the failure 5 years before, yeah, 5 years since now from before, yeah. So the analysis itself, and then we have such a concept paradigms. Then we could predict the equipment breakdown when the equipment is breakdown. So we could manage our forecasting of the budgets in this first year and the second years. We could mapping, yeah, our budget to synchron the target to synchronize with the company's profit. Yeah. So it's very useful because if the analysis is like this, yeah, if we have a car, yeah, a car in our house, and then we not every 200 kilometers not change the oil, not change the filters, and then break down, and after 3 years utilization, yeah. If we do the maintenance, then it will stay the age until 5 years or 10 years. Then if you see in the 5 years term range between the profit, then the comparison is would be better if we maintain our equipment more than if in 1 year our car is broken. Yeah, then the life the failure is maybe 3 years not broken in our equipment. I hope that answered the question. Yeah.
Okay, Mr. Amzan, this is the last question. How was the OPEX improvement on CMMS and big data system tool to maintenance costs, or will adjust other things, then the price on natural gas will stable then decreasing in the future? Is there any data annual cost pipeline on using CMMS to improve significantly? Please to answer this question.
Okay, so CMMS probably a lot of company use that by Oracle or SAP. Yeah? For example, SAP, we could enter the maintenance activities, our material. So generate the purchase request, purchase order, and the surface acceptance, and also payroll of the company itself. Yeah. So SAP is a great tool, yeah, because we could connect all of the function into one system. Yeah. So if we compare, if we not use SAP of either integrated software, so these companies would have a lot of application, because nowadays we should have the app. Yeah, because of COVID, a lot of persons stay at home. So to organize, we have to use the app. Yeah. We cannot overlook, yeah, the internet to use in our work. Yeah. So comparison, the company that use a lot of apps between the company that use only SIP, yeah, to connect between operation department, maintenance, financial, human resource, yeah, inventory, and so on, using one software, then using a lot of software. Well, it's still less cost, yeah, if we use the integrated software, because it will lower our OPEX. Yeah. So if you mention about the cost of the pipeline itself, the cost of the pipeline is depend. Yeah, there is a lot of factor. Yeah, maintenance costs. Yeah, the operational costs, and then the social costs, and then the rent of the land itself. There's a lot of component of the cost itself. Yeah, but if we could manage the maintenance costs, yeah, such as the pipeline, we manage itself. There is no downtime. Uh, there is no downtime. If there is a downtime, probably three days. Yeah, and there is a lot of high cost. Yeah, because 100 MMSCFD times the dollar itself times 3 times 24 hours. How a lot of revenue of the profit of the company will reduce, yeah, if the pipeline not deliver the gas, and the complaint of the society itself, and the gas uh, dispersed, yeah, to the house, and then there is a fire itself, and the company image will be bad, yeah. So there's a trade-off of the company itself. So it's with better if we manage our maintenance activity. So the income profit of the company itself will be stay optimized. I hope that answer your question. Thank you.
Okay, Mr. Ramzan. Looks like we answer all your questions. Anything you would like to add or mention?
Okay. My statement is think this digitalization transformation not a single journey, the long journey, yeah. Because the OPEX will be higher, yeah, but it could get faster in the decision making, yeah. So we have to use the app now because COVID-19 we have to stay at home. So if integrated software we manage in our company, then it will increase our profit, our image, and our teamwork, yeah, to achieve the increasing of the profit of the business gas downstream. Thank you very much. I hope you enjoy my presentation and question and ask.
Okay, thank you for the first presentation from Mr. Amzan Iftari. Moving on the second presentation by Mr. Ganjar Alistiawan. And I will present to you. And I will present to you the speaker short biography. If you have any question, just send it in the chat box and later we will select the best question. Ganjar Alistiawan is currently a manager of infrastructure management and optimization with over 12 years of experience working in Indonesia National Gas Company, PT Pertamina Gas. Mr. Ganjar specialized in natural gas pipeline operation and rotating gas compressor. He is responsible for optimizing pipeline operation, assets infrastructure, and digital transformation program. He graduated in 2007 from Institut Teknologi Bandung with bachelor's degree in mechanical engineering. Now, let's begin with Mr. Ganjar Ali Setiawan presentation. Please welcome to Mr. Ganjar Ali Setiawan to give your presentation now.
Good evening, distinguished ladies and gentlemen. It is a great pleasure for me to join all of you today in this webinar. In previous session, we have gained a lot of knowledge about gas globally. Now I will give you an overview, a closer look of what happened inside the gas pipeline. I will speak on the subject gas management system, gas study, mitigation of gas transmission pipeline discrepancy. First of all, I need to explain about the open access pipeline system. There are four parties in an open access pipeline system. gas transporter who own the pipeline, shipper who own the gas, off-taker who use the gas, and producer who produce the gas. Both off-taker and producer can be a shipper, depends on the location of the gas cells, whether it is in the wellhead or plant gap. This is the illustration of gas transmission pipeline. There are two shippers using this gas pipeline. Shipper 1 needs to deliver gas from receipt point metering A to delivery point metering A, while shipper 2 needs to deliver gas from receipt point metering 2 to delivery point metering B. In reality, the open access pipeline system may consist of several shippers, hundreds of receipt points and delivery point meters, also various gas composition. All shippers will put their gas into one pipeline system. They will mix all together in this pipeline. So, how to identify gas ownership inside that pipeline? The answer is gas management system. Each shipper has its own account. Even though the gas in the pipeline are mixed, each shipper gas ownership data is recorded based on the energy entered and received method and the energy out in the delivery method. To ensure the transporter can manage all shipper accounts, the system needs to record the full data cycle. All data originating from the metering system and field instruments will be sent into the operation control of each area. Then data from all areas will be collected in the headquarter database to be processed as needed for operational dashboard and processed further as an input for another software such as GIS or ERP. Here are the operational key parameters that transporters should concern. First, shipper account, then the train, then mixed gas composition, pipeline pressure, daily gas flow, and the last is discrepancy. This is our matter of concern. What is discrepancy? If we look at the illustration in the left below, the pipeline system consists of gas stock shipper plus initial fill. If we sum this gas stock shipper and initial fill, it should be the same as calculated gas stock or line pack. That's the ideal condition. Calculated gas stock minus initial fill minus gas stock equal to 0. But that never happened in reality. This 0 number will be some number, then it's called discrepancy. From this formula we can see, so discrepancy is calculated gas stock minus initial fill minus closing stock, while closing stock is the equation of opening stock or last day stock plus meter reading, receipt point meter reading, delivery point meter reading, fuel, flare, and condensate. Or we can call this gas balance current period. The discrepancy formula is regulated in a document called access arrangement, agreed by the parties and approved by the government. Discrepancy calculation uses an energy basis so that the measurement gas volume in metering must be converted into energy. The maximum discrepancy limit in an open access transmission pipeline system varies depending on the agreement of the parties. So how important is to control discrepancy? I'll put some illustration. Let's say a 400 mm SGF per day of natural gas enter an open access transmission pipeline. The gas price average $6 per MMBtu. Average toll fee is $0.15 per MCF. See the illustration. The receipt point, gas entered in the receipt point is 400 mm SGF per day. But when the gas came out in delivery point, The number is 400 mmSCFD plus minus discrepancy. The gas come in will not be exactly the same as gas came out. So this is called discrepancy. It can be plus, it can be minus. So when we put this parameter I put in this table, I put three variables: discrepancy 1%, 1.5, and 2%. With the same gas flow, same heating value, same price, same toll fee, the effect is plus minus 24 US dollar per day to 40,000 US dollar per day. The financial impact on the toll fee, 600 US dollar per day up to 1,200 US dollar per day. Can you imagine what happened in 1 year? It's very big number. The discrepancy will impact the financial very significant. If the dependent variable go up, so all independent variable will go up. So this discrepancy is very important to maintain. That's why we have to maintain the discrepancy close to zero. What's the factor affecting discrepancy? In the previous slide, we see the formula of discrepancy. One of the factor is line pack. Line pack refers to the volume of gas that can be stored in a gas pipeline. The operational implication of line pack means that the gas volume of gas injected into a pipeline can be greater than the volume of gas withdrawn from the pipeline. It can be calculated using two ways: a manual calculation using formula below or software calculation. The critical step for software calculation is creating a pipeline model that's accurate with the pipeline. Then we can have the line pack calculation. Second factor is initial fill. Initial fill is a minimum total amount of natural gas in volume converted into energy based on the weighted average gross heating value contained in the pipeline system, which is required for natural gas to flow at a certain pressure difference between the receiving point and delivery point. The amount of it is determined by the transporter. So initial fill is just like the same as line pack. So what's the difference of line pack and an initial fill? So initial fill is the minimum amount of line pack that must be provided by the shipper so that gas can flow in accordance with the minimum pressure condition for the pipeline. While line pack is the amount of gas that is actually stored in the pipe, calculated every day. How to calculate is all the same with the line pack. And the third parameter is shipper stock or closing stock. From the illustration, we can see that closing stock formula is daily stock, opening stock plus gas balance equal to closing stock. And this is the important one, the gas balance. In the closing stock, all parameters determined by the meter reading in receipt point meter, delivery point meter, fuel and flare or condensate meter reading or calculation. Each shipper has an account which will be updated every day by the transporter as a daily stock report to report the opening stock of the next day, and so on. The process will be repeat itself every day. This is the possible root cause. What can make a high discrepancy? Using a fishbone diagram, we can map by category each root cause of the problem. Based on the diagram, there are 14 possible root causes. To find which causal factor have a most significant impact, one by one of the root cause must be examined. The root cause in here we can generate from the three factors I explained before. And then we are talking about root cause stratification. From 14 root cause, we want to know which root cause is the most significant or have the most significant impact to the discrepancy. On our case study, we are using open access pipe, 523 kilometer pipe length, 6 to 32-inch pipe diameter, 117 stream meter consist orifice, USM turbine, and 2 natural gas laboratory, online and offline gas chromatograph, manual sampling every 1 week, and real-time data collection to one operation control room. And then from 14 possible root cause, we are trying to identify the relevancies. There are 3 factors that is irrelevant to the discrepancy, and we can ignore these 3 factors. And then the 11th factor, we're trying to see the impact, and then we put the percentage of significance. After we put the significance, we can draw a waterfall, possible root cause stratification, and we can determine which is the dominant root cause. You can see the field instrument failure, broken metal flat, is the most significant factor that can impact the discrepancy, followed by pipeline system modeling, calculated gas stock formula, substandard meter configuration, gas sampling method, uncalibrated method, significant gas composition variance, heavy friction condensation, leakage and venting, data transfer failure, and gas standard that has much different specification from gas to be analyzed. From these 11 possible causes, we are only solve 9 problems. Since these 2 last factor is very low impact to the problem, we will ignore this root cause, and we are trying to focus in area of attack from field instrument failure to leakage and venting. And how to solve all this problem? We are doing this mitigation list of action. First, we are ensure that configuration parameter of the entire meter system, including flow computer, are in accordance with operational condition. We can see how important flow computer parameter. If there are deviation of 1 degree Celsius, this will take effect to 0.33% accuracy. Pressure deviation 0.5 bar will take effect 5% to accuracy. Every 100 meter increase in elevation will cause the volume measurement to decrease by 0.1%. So it's important to set atmospheric pressure precisely in the flow computer based on the elevation from sea level. Second, we have to make sure the entire meter system are calibrated. We check the schedule more frequent meter loop tests for meter with gas flow above 5 mm SCFD. Let's say this meter loop test schedule is 6 months. When we are doing this mitigation, we're trying to shorten the period. We are doing meter loop test every 3 months. Then we have to check the entire pipeline system for potential leakage. We evaluate the pipe system model and make adjustment to the last condition. Since we are operating very dynamic pipeline system with various gas composition, there are new branch, new pipe segment. So we have to evaluate the system model. We make adjustment. We put another new pipe segment. We enhance the calculation so it can be more accurate. And then we have to evaluate all line fact formula parameter according to current condition. The most important is specific gravity calculation. We have to set the right specific gravity calculation on flow computer, or we can do specific gravity manual correction. But it is better to set specific gravity calculation on flow computer rather than manual correction. Then we have to rearrange the schedule for manual gas sampling so that it can be done simultaneously. The problem is when you have multiple receipt point and delivery point, if you take the gas sample in the different time, it is possible the gas will change the composition dramatically. So it is the best for you to take the gas samplings in the same time, both in the receipt point method and delivery point method. Later, we have to cover all idle lanes with blind flange or spectacle blind to ensure no gas passing to the unused pipe or to the system that are not included or not reading in the pipeline model. Then we have to perform inter-laboratory lab check to make sure there is no outlier when doing gas analysis. This is important since we are still using manual gas sampling calculation. So we have to calculate gas composition in our lab. If you have a automatic gas sampler and automatic gas chromatograph, maybe you can skip this problem and just to make sure that your online gas chromatograph running well with tubing in all meter system to make sure it's not clogged. Some of the meter will read the gas flow wrong because of condensate clogging the tubing to the transmitter. So transmitter will read the wrong pressure and then they will result in the false meter reading. And what you have to do, you have to create a condensate trap if a condensate or liquid is found in the tubing meter. When you are doing this, you have doing this truly to all your meters in receipt point and delivery point. The large number of meter stream and the size of the area to be checked has resulted this all 10 program being carried out for 1 year and being continuously updated to look for improvement that are still possible. Finding the root cause of many influencing factors and ensure that the mitigation carried out is the right on target is very, very difficult. And then this is the result. In 2019, we have a discrepancy minus 2.3%, and now we have discrepancy average on minus 0.9%. This is good progress. We are in October, we can reach minus 0.2% near zero. So this means our progress, our effort is paid. We can make a discrepancy close to zero. And in conclusion, as a prudent gas transporter company, maintaining a discrepancy close to zero is a responsibility that must continue to be carried out. Finding the root cause of discrepancy and carrying out appropriate mitigation is an iterative process that requires knowledge, thoroughness, cooperation, and persistence. The operational condition of the open access pipeline with gas source from various gas wells are very dynamic and always change from time to time. So keeping the discrepancy close to zero is a job that is always challenging to handle. Maintaining discrepancy is not a project that has a completion target. It is activity that will continue throughout the pipeline operation. And that's for me. Thank you for your attention. Any question?
Thank you, Mr. Ganjar Alistiawan, for the insightful presentation about case study and best practice in natural gas metering system. Now, shall we begin to the Q&A session to keep this on schedule? For the Q&A session, we have selected the best question, and now I will tell you the first question. The first question is, how do you elaborate further about lack of manpower competencies in your slide regarding discrepancy? Now, please, Mr. Ganjar, to answer this question.
Okay, thank you for your question. The operational of metering system is very complex and require a high experience and high knowledge about AGA system meter, how to read meter, how to set the parameter. And in terms of lack of competencies, we confident that our personnel is capable of setting this parameter, and all this parameter is regularly checked by our team, and every 1 year we are doing calibration with Dinas Metrologi, Ditjen Metrologi, DITMET. So we think that the lack of competency is not the one who causing the discrepancy. So I remove that factor because we understand what we are dealing with, and we are trying to find the root cause, what other factors that really harm to the discrepancy and make the discrepancy far from zero. That's my answer about the lack of competency. Thank you.
Okay, now we shall continue to the second question. That is, how the transporter action to reduce the discrepancy if already over than 2%? From your experience, how to explain this problem to all stakeholders? What's the implication if the discrepancy keep over? Please, Mr. Ganjar, to answer this question.
Okay. How to reduce the discrepancy if already than 2%? That's what I'm presenting at the last slide about the mitigation action that we are doing if we have discrepancy of over 2%. We are trying to find the root cause, because so many parameters can affect the discrepancy. We are usually doing an emergency meeting, and we are coordinating each other from one area to another area, because this area is very large. It's have 117 meter system. It is very complicated. So we have to find which meter causes this discrepancy. We are trying to find the meter with the higher flow, because if the meter has a high gas flow, the slight difference in accuracy, it can affect to the discrepancy very big. Let's say a meter 100 mmHg, they deviate 1% accuracy, and then the deviance of discrepancy up to 8 mmHg or 8 MMBTU. So that's what we are doing. We are looking for the priority, the meter which meter has the high gas flow rate, and we are looking for another parameters. Of course, we are looking for flow cone, possibility of leakage, and we are trying to doing a loop test, zero check, and other thing. So we want to reduce the discrepancy below 2%. And how to communicate with the stakeholder? This is the management part of dealing with discrepancy. So discrepancy is regulated in access arrangement. Everybody knows that no one's have a high discrepancy. Of course, shipper will take this discrepancy in the first time, and then we have to communicate with all the shippers, and then we will communicate to them what happened and what we are doing to reduce the discrepancy. Usually, discrepancy is happen not only from internal factor, it's sometimes it happen from external factor. Let's say some of the meters of some of the meters had by another company, or there's any leakage caused by third-party activities, or another thing that so many variables in here. So we, in general, we have to communicate honestly and clearly to all stakeholders what is happening and what we are doing to reduce the discrepancy. And the implication if the discrepancy keep over, of course, there will be of some of the financial aspect based on access arrangement. But if that not regulated on access arrangement, this will be harmful to the image of the company. We can say that the company is not prudent, or the shipper maybe feel they have disadvantage using this pipeline open system, etc. All these images are bad and negative image. So what we are trying to do is to make discrepancies closest to zero. That's my answer. Thank you.
Okay, for the next question, how to calculate the transportation cost or toll fee in using pipeline infrastructure? Have a formula? What is calculate basis to determine the cost or toll fee? Mr. Ganjar Alistiawan, to answer this question, please.
Okay, so this is more to commercial aspect, I think. Well, the toll fee system in Indonesia regulated by BPH Migas. As a transporter, we can send a number to the regulator. We calculated based on our project economic, of course. There are three parameters in determining the toll fee of pipeline transportation. First is the volume. How much the volume will be entered into the pipeline. The second is capex, or we say in the formula is nilai basis aset. Nilai basis aset, volume, and third is the operation and maintenance cost of the pipeline. That three factors, we have a formula in BPH Migas. Every transporter using that formula, and that's regulated by the government. We can calculate our operation and maintenance cost yearly. We have our nilai basis asset, or the capex, capital expenditure of that pipeline. And the third parameter is the parameter defined by the shipper. How much shipper will transfer the gas? Let's say if the shipper only transfer a small amount of volume, of course the toll fee will be high. But if the shipper transfer a high volume of hundreds MMSCF per day, of course the toll fee will go lower. That's the economic laws. If you have a high revenue, then the cost will be down, because the project economic will be greater, or IRR of the project is set as the project economic when we building this pipeline. In Indonesia, if we want to build open access pipeline, it is an open tender system. Each company can propose how much they can build, how much dollar they can building this segment of pipeline. Of course, each company has its own internal rate of return, IRR. So that IRR will be carried out to setting the pipeline transportation cost or toll fee. This mechanism is open and coordinated by BPH Migas. If there are one pipe segment doesn't have a toll fee, the transporter should propose some value. The BPH will review it and they will invite all shipper in that pipeline. The process is open and it's using a clear formula. So I think it's very good. The government have this regulation on to determine the toll fee for each pipeline segment. That's from me. Thank you.
Okay, Mr. Ganjar, for the next question is there any penalty if the discrepancy is more than what is in the contract, when we are sure the meter system, calibration, and others are appropriate, but discrepancy remains high? How do we solve it? Please answer
Again,
this
is the management approach for to all parties. As I said, in the discrepancy number is stated in the access arrangement document. Some of the access arrangement put a penalty to the transporter if the discrepancy higher than that number. So the transporter should give some penalty or will have to pay some amount of money to the shipper to change the gas losses. But before we are going to that penalty, the transporter can discuss to all the shipper what makes this discrepancy high. In my experience, the discrepancy high mostly because of the metering system. Mostly of the metering system, the instrument failure, condensate clog, or seal orifice broken, so the gas pass and not read in the meter system. Then we are trying to find the root cause. If a root cause is caused by the asset of the shipper, then the transporter will not pay a penalty, but we fix it together because some of the meter system not owned by the transporter, but it's owned by the shipper. And then if all thing is in great condition, and then something happen like a leakage or pipe burst caused by third party or caused by misoperation or that other thing, usually it will impact a small amount to discrepancy. In my experience, we have a mainline valve that can block if one segment is burst or leakage to atmosphere. Then we can immediately shut off the valve to prevent the further leakage into the atmosphere. The gas go to the atmosphere is only gas that inside that segment, let's say about 7 or 10 kilometers in the pipeline, and that's not too much. That's not affecting too much the discrepancy. Just like I show you in the significancy, leakage and venting is not too significant, except you have a fatal burst that nothing can do. And gas continue flowing to the atmosphere. It's maybe another story, but we are not experiencing it until today, and Alhamdulillah. That's my answer. So of course there will be a consequence if transporter cannot prove that the discrepancy is caused by misoperation or misconduct. Okay, maybe that's answer your question. Thank you.
Okay, and finally, this is the last question. The last question is, if there is one supplier entering the gas at open access, then there are several instrument equipment failed, causing matter discrepancy between shipper and off-taker, so that it causes
So sorry, I think I lost Miss Desti. Can you repeat the question? The last statement.
Okay, let me repeat for you. The last question is, if there is one supplier entering the gas at open access, then there are several instrument equipment failed, causing matter discrepancy between shipper and off-taker, so that it causes mismeasurement. How is the mechanism and solve the problem?
Okay, in daily operation, we are calculating this discrepancy on a monthly basis, not in a daily. In a daily basis, we are just doing for self-checking, but the impact to the shipper, usually we do it monthly. Every month, every end of the month, we calculate all the shipper stock, and then we do some correction to the shipper stock based on that month discrepancy number. So if something happen in say a failed instrument, because we are using real-time operation data, we can see the real-time data every minute from every metering in our pipeline system. So we notice it immediately if there's something not right. Let's say if the number is freezing, they don't move, that must be something happen to the metering system or the instrument, or there's some anomaly. The volume read in that meters is unusual. This unusual. Let's say it's usually 10 mmSCF, but accident then it reading it become 8 or 7 or 12 or 13. We will contact the shipper. Is there any something happened to your gas entering our system, because there's some changing in our meter reading? We first have to clarify to the shipper. If the shipper say that we do nothing, we are flowing the same gas every day, then we are sure that something wrong with our meter, and immediately in response in hours, we immediately go to that meter to the site. We do some checking and calibrating, zero check and other thing to make sure that the meter is okay and to back to the good condition. So usually if something happens if in the instrument, we will act immediately, and that's only affect the discrepancy in one day. If we calculate the discrepancy in 1 month, it will not be significant. So that's what happened in in the real case. So the mechanism is, of course, we first we find the potential root cause of this discrepancy, and then if we find the root cause, we then mitigate by repair it. And if we don't find the root cause, it will go along the day of the month, and then in the end of the month, boom, the discrepancy number will be high. Then when it happens, as I mentioned before, we will talk to the shipper and to the all shipper that are in the pipeline. We are discussing about what could be wrong in this pipeline system, and we're trying to find the root cause. And if there is misoperation or misconduct in transporter side based on access arrangement, then the transporter have to do some responsibility. That my answer to the last question, and thank you for your attention and your eagerness about this discrepancy.
Okay, Mr. Ganjar Alistiawan, there is still have one question. Maybe the last question. The last question is the contribution in discrepancy from of determination of gas composition using the different gas standards is relative low, about 0.67%. The determination of gas composition should be related to the caloric value and the quality of natural gas, and further will be related to the price of natural gas. I think the contribution due to the mistake or inaccuracy determination of gas composition can be significant to discrepancy. Please give your opinion and experience about this matter.
Okay, thank you. That's a very deep question. Of course, I have experience that in that case. So, just I said in my presentation, we have two laboratoriums doing gas composition analysis. In those two laboratoriums, we are using different gas standard. While the laboratorium one, they are using gas standard of the mixed gas. And then the second laboratorium, we are using the gas standard, the composition near the mixed gas. But in the second laboratorium, we make a gas standard nearly the composition with the CO2 content. The first lab without CO2 content, and the second lab with CO2 content. Those two gas standards create different measurement in the gas composition analysis. Using the same gas sampling, we take two gas sampling from the same inlet meter point, and then the sampling one go to the lab 1, and the sampling 2 go to the lab 2. Sampling 1 to the lab with gas standard with without CO2 composition, and lab 2 go to the lab with CO2 composition. And we compare the gas composition analysis measurement, and then the number is slightly different. It's not much different in the result of the analysis. While the real gas has CO2 composition. Meanwhile, in the real gas has CO2 composition, and we are using gas standard with or without the CO2 composition. It's resulting in the same calculations, relatively same calculation, not too much deviation on gross heating value. So from that experiment, conclude that the variation of gas standard used by the laboratory not impacting too much to the energy measurement or gas heating value measurement. That's the experiment I'm doing in 2019. And then another sample we are sent to the LEMI gas. And then we compare the three results from the same same gas source, but analyze using different gas standard. The number is not too much different. It's just slightly different. That's my answer.
Okay, thank you, Mr. Ganjar Listiawan. Is there anything else you would like to add or mention?
Okay, thank you very much for your time. And in the last speech, I will say thanks. And the final speech is about the maintaining discrepancy is not easy task. It's a very challenging job that we have to do it every day. We have to maintain it every time. So that's what the real operation doing. We are maintaining discrepancy close to zero, so we can prove that our company is a prudent transport company. We have a man with a suitable competency operating this pipeline. Okay, that's from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, we will have praying break with 30 minutes time, and the webinar for the next session will be back at 18:30 p.m. Okay, thank you all.
We shall continue on to the third speaker. The third speaker is Mr. Bahman Tauhidi, and I will present to you the speaker's short biography. Mr. Bahman Tauhidi has a BSc Chemical Engineering and PhD in Petroleum Engineering. He leads a research group in the Institute of Geoenergy Engineering, Heriot-Watt University. He is the director of International Center of Gas Hydrate Research and the Center of Flow Assurance Research, CFAR, at Institute of Geoenergy Engineering, IGE, Heriot-Watt University, with several. He has more than 50 publications and 13 patents. Now, let's begin with Mr. Bahman Tauhidi presentation. I remind you again, if you have any question, just send it to the chat box and later we will select the best question. Thank you. Please, to Mr. Bahman Tauhidi.
Can you hear me?
Yep, loud and clear, sir.
Right. If I get, can you see my screen?
Yep.
Okay. Good afternoon. I have the pleasure of being in your lovely country in 2005, long time ago. I remember your good hospitality and friendship, fantastic food, good scenery. I have very good memories. I delivered 2 hydrate rigs. One of them was very advanced, even better than ours, to Limigas. So I hope that still they are working. So the title of my presentation is Hydrate Best Practices in Hydrate Management. I'm very pleased to be at this meeting. So what are hydrates? Hydrates are crystalline compound formed as a combination of water and gas molecule. They look like ice, but they can form at temperature above 0. The necessary condition for their formation is presence of water or ice and suitable condition for suitable gas size, because if it is too big, it won't fit in the cavity, and suitable condition of pressure and temperature. So here in this figure here, you can see the red points or sphere are oxygen, the white are hydrogen. So this is hydrogen bonding, forming a cage that the gas molecule go inside this cage. And because of certain angle, 104.5 degree, they can have like Lego game. You can have different shape and structure. And the green one is the gas molecule. Normally, hydrogen bonding, each compound can exist in 3 phases. If you forget about plasma condition, gas, liquid, and solid. Here, hydrogen bonding is strong bonding and can form fix the position of the molecules and therefore forming ice. But when we have a gas molecule, which can go here, then there is van der Waals forces between gas molecule and hydrogen and oxygen. and that is work as an extra attraction term and stabilize hydrated structure at much higher temperature. The suitable condition, pressure, and temperature is represented by this line. Position of this line depend on the composition of the gas and composition of water. The reason composition of the gas, because the position of the oxygen molecule is relatively fixed. So the van der Waals forces is depending on the size of gas. So if you have a large gas, this distance is lower, van der Waals forces are stronger. If you have a small gas like nitrogen, the van der Waals forces are weaker, so therefore it's more difficult to form hydrate.
I'm so sorry, Mr. Bahman. Sorry to
Yes.
interrupt you. Could you make full screen of your slide, because I see the presentation is not in full screen, sir.
I made it full screen. Just let's see. Disconnect this one. Let's see again. Is it full screen now? It's okay now?
Yes, yes. This is okay. Thank you, Mr. Bahman.
Yeah. Okay.
It's okay.
So here, imagine this is the one gas molecule, and imagine another gas molecule is here. If the gas molecule are separate from each other, the energy is 0. When they get closer to each other, the nucleus and electron cloud shift and they attract each other. And when they get too close, they repel each other. So for that reason, some components, they have a stronger tendency to form hydrate, and some components have lower tendency. For example, among natural gas components, isobutane is very strong hydrate former because it's spherical. On the other hand, normal butane is very difficult to form hydrate because it's linear and it's too big to fit in the structure. So you can see that different components play a role on where this hydrate phase boundary can be. On the other hand, the other parameter is composition of aqueous phase. If anything dissolves in aqueous phase, water molecules are busy dissolving and there is less tendency to form hydrate. We use that property to control hydrate formation. For example, we inject methanol or glycol. That will reduce activity of water, therefore more difficult to form hydrate. So remember, if the hydrate phase boundary is the first thing you do, either experimentally or modeling, and depend on the composition of the gas and composition of water. Here you can see hydrate formation in the video. You can see that hydrates forming. Obviously, this is much faster than actual condition. So how we design for hydrate? So first we need to find hydrate phase boundary. This dashed line is hydrate phase boundary for the gas and water that we have. Then we need to look at the pipeline condition. This is pipeline condition. And then we superimpose the two. But engineer, so that is superimposition. So we superimpose here. And this is hydrate phase boundary. And this is the condition of the pipeline. But engineer, they take a safety margin. that safety margin can be 3 to 5 degrees normally. So we shift the hydrate phase boundary to the right, that's 3 to 5 degrees, or we shift the operating condition, pipeline condition to the left, 3 to 5 degrees. So that's a safety margin that we take into account. The amount of inhibitor goes to hydrocarbon phase and a percentage increase in the amount of inhibitor because of bad mixing. Okay, so we end up with something like this. So this system is going to form hydrate and cause problem for us. So what are the options? This is a pipeline condition, and onshore, this is offshore production unit, and this is a pipeline temperature and pressure. Initially, when it comes out of the wellhead, is warm, and then gradually cool down. So the option we have to avoid hydrate formation is removing water, that's dehydration, controlling system temperature, reducing system pressure, injection of thermodynamic inhibitor, using low dose hydrating inhibitor, anti-agglomerant, combination of these on a new concept which is called cold flow. I explain them in a bit more now. So imagine the operating condition is here, this operating condition, the worst operating condition. Here you see the effect of water content, dehydration. If we reduce the amount of water in the gas phase, how will that impact the hydrate phase boundary? You can see that 500 ppm is here, 200 ppm water. This is water in the gas. 150 is here. Still we are inside hydrate region. 100 ppm is ideal because we have a safety margin and we are outside hydrate phase boundary. So dehydration is one of the options to avoid hydrate formation. The other one, for example, this is wellhead condition and then cool down along the pipeline. We go inside hydrate phase boundary. We can either preserve the heat, especially in case of liquid hydrocarbon, or use direct heating. So we heat the pipeline to keep the system outside hydrate phase boundary. Another option is reducing pressure. But you see that here we are going inside hydrate phase boundary. If we reduce the pressure, we come outside. But normally we don't do that. The reason is that pressure is energy. We don't want to waste the energy. So normally we don't change pressure unless we have a blockage and we want to remove the blockage. The other option, imagine the operating condition is here, this red dot. Another option is that to inject inhibitor. This is a concentration of MEG. This is 10%, 20%, 30%. 40%, we are inside hydrate phase boundary. Maybe we need 50% MEG to prevent hydrate formation. The other one is using kinetic hydrate inhibitor. So kinetic hydrate inhibitor, the benefit of kinetic hydrate inhibitor, they are effective between 1 to 3% of water phase. So they reduce the amount of inhibitor. For example, in previous slide, you'll notice that we need 50% inhibitor. Here we need 1 to 2% inhibitor. So it is ideal for offshore development because offshore development, you have limitation with respect to space and weight. So the storage state or pump space and weight are important in offshore development. But for testing these chemical, we look at the minimum temperature and maximum pressure. So maximum pressure normally shut-in wellhead pressure, we use that. Minimum temperature is seabed, minimum seabed temperature over 100 years, you know. So it's very conservative. So we put the condition at that condition of the cell and that condition, and we cool down the cell. And then as we cool down, the gas will contract and then the pressure will drop. And then you see that the pressure is constant, so no hydrate formation. And then here is hydrate formation. We can see because hydrate takes a lot of gas, so we see significant drop in the pressure. But also another point to observe is the temperature increase. That shows that hydrate formation is exothermic, create heat. So you can see the temperature of the system goes up. So if you look at this, you know, from 200 minutes to 1400 minutes, this chemical prevented hydrate formation. That is 20 hours. So this chemical can prevent hydrate formation for 20 hours. So if the fluid residence time is less than 20 hours, we can use this chemical, okay? So that's another option. The other option is using antiagglomerant. Antiagglomerants are chemicals that do not prevent hydrate formation, but they prevent hydrate agglomeration. You see that this is with chemical, this is without chemical. You see that here they are agglomerating. So to test this, we have this rocking cell, a visual rocking, and other devices. That this is the ball moving up and down, and this is hydrate slurry that we have produced by adding chemical to system. And you can see that it's completely transportable, and there is no deposition on the wall. So that's ideal. This system is ideal. But I believe that this is conservative. It is because here the gravity the only force, and in reality, pipeline, in addition to gravity, you have pressure. So that's another technique. We can use combination of these. We can use insulation plus inhibitor, heating plus inhibitor, kinetic hydrate inhibitor plus thermodynamic inhibitor, anti-agglomerant with chemical inhibitor, formation water and organic inhibitor. So you have different options to combine them. So the last one is cold flow. Cold flow is that this is good for offshore development, because offshore development is cost of pipeline is very high. And then if you have insulation, it becomes at least twice, you know, this is my understanding, but it's very expensive. So what we want, no heating, no insulation, that will reduce the capital cost. And allowing and promoting hydrate formation, but preventing the agglomeration. So how we prevent agglomeration? There are various options. Providing seed of hydrate formation using anti-agglomerant, natural inhibitor. There are in the oil, there are components, especially asphaltenic component, that can create emulsion, and they can disperse hydrate crystal. Mechanical means under-inhibited system. Under-inhibited system is a system that for example, you need 30% MEG, but you inject 25% MEG. So some water become hydrate because the inhibitor does not go in hydrate structure. The concentration of inhibitor in remaining water will increase and prevent further hydrate formation. Therefore, it is under-inhibited and can transport hydrated slowly, or a combination of these options. So these are all conventional prevention techniques, okay? Now, these are initially the consultant or the company that designed the system for us, we recommend, okay? So what happened with time? Yeah, with time, we expect the ambient temperature or pipeline temperature to change on a daily or that's what we expect. But we don't normally take into account the inject a maximum based on minimum temperature over 100 years. So we are injecting a lot of inhibitor. Reservoir pressure will drop. After production, reservoir pressure will drop. So reduction in pressure means that less drive for hydrate formation, but the residence time will increase. But still, we don't change. Normally, we don't change the inhibitor concentration. Water cut may change. Water cut normally will increase. When it increases, it reduces the amount of inhibitor because you are injecting inhibitor at constant rate. Water cut increases, the concentration in the aqueous phase will drop. So there is a risk of hydrate formation. Or we might have formation water. Formation water, salt is an inhibitor itself. So we need less inhibitor, but we still continue the same amount of inhibitor. Inhibitor partition, inhibitor going to different phases, that can change. The pump may fail or human error, or we can have the inhibitor not the same quality. For example, you have a MEG regeneration unit, you expect 80% reach green MEG, but it is 70%. But obviously that will impact your amount of inhibitor. So industrial practice is that we don't change anything. Okay, we continue with that. And for KHI, in some countries, like in Persian Gulf, Qatar, they inject inhibitor in beginning late autumn, covering winter and spring, but the same rate. While in autumn or late spring, you need less inhibitor. The design of pipeline in the worst condition, which we don't need that, and that will result in too much inhibitor and sometimes too little inhibitor, because if you have water cut increases, you might have too less inhibitor. Or there is a human error, you might have hydrate blockage. So how to prevent that? We have a project, 12 years project supported by different companies to develop technique for almost real-time monitoring of hydrate safety margin. For hydrate safety margin, what we need, we call it this hydrate safety margin. The minimum, point, the nearest point to hydrate phase boundary and the hydrate phase boundary. This is safety margin. We normally design this based on 3 to 5 degrees. So we want to monitor this, okay? So for monitoring this, we need to plot this line and we need to plot hydrate line. For this line, we can use computer model, or we can use minimum seabed temperature and inlet pressure in the pipeline. Then this line, hydrate phase boundary, we need composition of hydrocarbon phase and we need the composition of water phase. Composition of hydrocarbon phase doesn't change with time normally. So the same hydrocarbon. The only question is that what is the composition of aqueous phase? Normally, we need to send the sample to offshore or onshore lab to determine the amount of salt and inhibitor. And they use chemical technique to determine, and it will take 12 to 24 hours to get the result. What we have done here, we design this device that we hope and we are basically being applied for online monitoring. So remote monitoring using Internet of Things. So this device, what we measure electrical conductivity. This device for measuring electrical conductivity and temperature. And speed of sound, this is speed of sound measurement. Speed of sound and conductivity is like two equations, two unknowns. From this computer model, we can, from this data, we can determine the amount of salt and inhibitor, any inhibitor. It can be KHI, it can be MEG, it can be methanol, ethanol, whatever. And if we don't have any water at all, there is another technique to use the same principle. And it takes only 5 seconds to determine the amount of inhibitor. And if you want to see more about it, is YouTube film will show. So we know the hydrocarbon composition. We found the concentration of different hydrate preventer, and we send it to a computer model. You can use your model or any model. And if we determine the hydrate phase boundary, so this is hydrate phase boundary depending on how much inhibitor you have. And you can determine the pipeline condition. If pipeline condition is here, we are inside hydrate and can cause a hydrate problem. If the hydrate phase boundary is here, we are outside, but there is not much safety margin. If the hydrate phase boundary is here, then that's ideal. If hydrate phase boundary is here, you are injecting too much inhibitor. You are wasting money, okay? So this is a real case application by Total. Here you see that initially the pipeline condition was around 5 degrees. You know, the worst condition was 5 degrees. The pressure of the reservoir was 150 bar. And you see that at that time, they needed 28% methanol. But after a few years production, then you see that the pipeline pressure has dropped to 70 bar. And most days, they don't have any hydrate problem, but it's still they were injecting 28%. Then they noticed that, well, this is causing pollution because methanol is a poison for catalysts, and you know, reduce the quality of condensate. So we help them to reduce the amount of inhibitor from 28% to 5%. After a while, the amount of water is increased, and they couldn't even maintain that 5%. So they decide at the time with the amount of water increase, the salinity of water will increase because the formation water has 4.5% salt. So they decided not to inject inhibitor at all. And we did some tests. We realized that up to 20% hydrate will not block the pipeline, but we put the design based on 5% hydrated slurry. So we were operating inside hydrate phase boundary. And here you can see that the salinity, assume that salinity around 4.5%. It's more than 4.5%, 4.75. Just for simplicity, I assume 4.5%. If 10% is converted to hydrate, then the amount of salt would be 5%. That means that you have 10% hydrate, and you shouldn't go above that. So here you see that they didn't notice that, and it blocked the pipeline. This is, you see that production reduced to 0. Chloride concentration, which comes later, from lab tests. And then you can see that this device was able to give them a 24 to 48 hours advance warning. So this device was deployed, reduced the amount of inhibitor to 0, and they managed the field which was supposed to be abandoned in 2010, was working up to 2016, producing 5 million barrel of oil equivalent. It's published in that SP paper. So in summary and conclusion, there are various techniques for avoiding hydrate blockage. There are areas of improvement in the current technique I discussed. There are devices and techniques that can be deployed for monitoring hydrate safety margin and early warning. We have this hydrate check, that device I show you in online version. Technique have been tested extensively in various laboratories. Technique for detecting early signs of hydrate formation was developed and tested that I didn't have time to present here. It provides extra safety measure against change in the system. Then we can calculate or calculate the risk and apply and use these devices within hydrate region. And with this, this device played a major role in university winning the Queen Anniversary Award in 2015. And the video is here. We were very happy to join the ceremony in Buckingham Palace in Queen's residence. So that's my last slide. I would like to take this opportunity and thank all sponsors for their financial and technical support. I thank you for your invitation. It was a pleasure to see you again, talk to my good friends in Indonesia, and thank you very much for your attention. Thank you.
Okay. Thank you, Mr. Bahman Soidi. Such a tremendous presentation, and I hope this presentation will give to all of us insight about best practices in hydrate management. Indeed, to shorten our time, shall we begin to Q&A session to keep this on schedule? Okay. For the first Q&A session, we have selected the best question, and I will tell you the first question is, okay, is there possible that hydrates happen in pipeline transmission, especially in a tropical country? What might cause it, and where the segment or part it probably happens?
Yes. Normally, offshore condition, in onshore condition, in hot climate, you shouldn't have hydrate problem unless you have a Joule-Thomson effect after the choke. Okay, Joule-Thomson effect, you have a choke to adjust the pressure and flow rate, and that creates Joule-Thomson effect, and that can result in hydrate formation. But if you are basically operating offshore condition, temperature can be very low depending whether it's open sea or not. So for example, in Malaysia, the temperature could be 15 degrees. But for deeper water, it can be 4 degrees, because 4-degree water is the heaviest water, and the temperature can be much lower. So 4 degrees, yeah, there is a possibility offshore to form hydrate. For example, your development, I believe you have some fields in common with Malaysia, and you can have hydrate problem there. Did I answer your question?
I hope that answered the attendance question, but we shall continue to the second question. That is how to reduce water in a gas that causes hydrates with the minimum inhibitors, perhaps with no inhibitor at all in terms of low cost.
Yeah. First, we need to see that how much dehydration we require. 100 ppm is good enough for us, or we need to have 10 ppm. Then we need to choose which technique we use. Basically, you can take the water to dehydration unit. That is dehydration unit. What you do, you have a tag flow that you inject the gas from bottom of the tower and tag from the top, and then you can reduce the amount of water. That's the simplest way of reducing water. But there are other options. You can use freezing, you can use silica gel, you can use different things to reduce the amount of water. Even methanol or glycol, injecting glycol and methanol, they reduce the amount of water in the gas phase. So yes, there are various techniques for reducing the amount of water in the gas phase.
Thank you, Mr. Bahman. We shall continue to the third question is, you mentioned that water salinity has a correlation with hydrate forming in the pipeline. What is the main factor that can make water salinity change in reservoir?
Water salinity is basically, as I mentioned, anything dissolving in water if it's not a hydrate form. Anything dissolved in water will reduce activity of water and prevent hydrate formation, okay? Now, why the salinity can change? Because initially, if the reservoir condition, we have gas. Gas is a state that the molecules are separated from each other. When they are separated from each other, then any molecule can go between them. So water can go between them. So like water is being evaporated. So when the water is evaporated, it doesn't take salt with it. So the water is a water in the vapor phase. When it moves toward the wellhead, the temperature will drop, and that will result in water to condense. Not all the water, a part of the water. So that will be condensed water, which doesn't have any salt. So initially, we are producing water with very little amount of salt. But later on, either the level of water increases, or we basically block some part, and then the gas is moving faster. And when you are moving faster, it will transfer the water as mist to the gas phase. Water as the mist in the form of water will have salt, so the salinity will change. Yeah? When salinity changes, there is less requirement for inhibitor. In fact, you have to react to that. Otherwise, you might not have hydrate problem, but you have a salt problem, the salt blockage problem. Because there is a difference between salt and inhibitor for methanol or glycol. Salt is soluble, but it has a solubility limit. For example, NaCl, you can dissolve 25% NaCl. But hydric inhibitor like methanol or glycol are miscible. The difference is that miscible, you can combine them at any proportion and become single phase. You can have 0% MEG or 100% MEG is single phase, okay? But salt, no, if it goes above 25%, it will solidify as salt, solid salt. When you inject, you are producing saline water. When you inject inhibitor, then you can have salt deposition because inhibitor is miscible, infinite solubility, but salt doesn't have this property. So we need to be aware of salt production because increasing salinity, because if you don't reduce the amount of inhibitor, you can have a blockage because of salt deposition. I hope I answered your question.
Thank you to Mr. Bahman. I think we still have 4 minutes for one question. Is it okay, Mr. Bahman?
Yes, sure.
Sure. Okay. Maybe this is the last question. You have mentioned if the reduced pressure is one of method to prevent hydrate form, but the pressure is energy, so it is not good option because we do not lose the pressure. So what kind of case it can be implemented?
Yeah, if the pressure, if the pressure is only, because pressure is energy, and any production engineer know that they have to reduce the energy loss in production. That's why we inject, we do perforation, we do acid job, we do different technique, increasing length of perforation or depth of perforation to reduce the pressure or design the tubing to reduce pressure. Okay. So we normally, because the pressure is energy, we don't want to lose it. But sometimes, if it's only 1 bar or 2 bar to get out of hydrate phase boundary, people do that. But that increase the load on compressor, okay? Because you need to transfer this gas and oil to a certain distance, and you need to use compressor. But we normally do not reduce pressure if we have blockage. If you have the blockage, then with the control system, you can reduce the amount of the reduce the pressure gradually to dissolve hydrate. So in general, you have to calculate how much will be the cost of the system if you reduce the pressure going out of the system, hydrate system, or we can use other techniques. So in general, we don't reduce pressure. If there is necessary to prevent hydrate formation, then we can use other techniques. For example, normally we use injection of inhibitor or kinetic hydrate inhibitor. So we use other technique to avoid losing energy of production. I hope I answered the question.
Okay, looks like we have all covered all of our questions. To Mr. Bahman, is there anything else you want to mention or add?
Please, you have my email address. I think you provide a copy of my slide to the audience or email addresses. If there is any question about, this presentation or other related presentation with respect to hydrate or the devices or technology that we have developed, I will be more than happy to answer your question.
Okay.
But thank you very much for the invitation. I hope to be able come and see you. I had very good time, very good food when I was in Malaysia. Have a good day and enjoy the rest of the conference. It was a very good conference. I learned a lot. Thank you very much.
Thank you very much, Mr. Bahman Tohidi. Okay, now we actually gone to the end of our agenda. The closing speech by Dr. Adrian Encoda. Please welcome Mr. Adrian Encoda.
Can you hear me now?
Loud and clear, sir.
Yeah, all right. So thank you so much for all of the participants. Of course, again, we feel so grateful to have Professor Bahman Tohidi with us as the last speaker for our webinar today. So basically, it's a part of the initiative, right? So it's a platform, it's a communications where we try to connect people or expert from the government, from the policy maker to the academia and also to the professional and within the industry itself. So it's very useful, it's very beneficial for all of us, and then we really wish that all of the participants can enjoy our international conference on gas management by engineering and technology. So it's the first time we wish to have another event inshallah next year, and then of course the topics perhaps is very useful. It's an eye and brainstorming for all of us. The thing for today, for this event, actually we talk about the natural gas outlook and market challenges. The first day yesterday, all of us really enjoyed a presentation from Pak Agus Budianto from SKM Gas, and then we have also a great speaker from the government yesterday, Pak Joko Siswanto from DEN, and then we have Pak Tom Seng from Tulsa University. And then our second day today, we have, we really enjoy a discussion and sharing knowledge from Pak Nur Zaman from a PGN, from Perusahaan Gas Negara, and also from Pak Ganjar. And then lately, we really enjoy a presentation from Professor Bahman from Water University from the Hyderabad. So well done. Hopefully, this event can be, a platform where we can communicate each other. Of course, within the energy mix subject, within the energy transitions, renewable energy, we can see very clear that there is a lot of benefit from the natural gas, where it's less environmental, effect, and then the demand, the benefit for the people is in terms of the fueling the demand and energy mix is quite very high. So it's bringing to the energy mix and energy transition. So hopefully, what we can learn from Pak Nur Ramzan this evening, this afternoon, is we learned about how the corporate pipeline management in terms of the maintenance, where we can use a type of the machine learning, IR 4.0 digitalization can give a lot of benefit in terms of the operations, expenditure, and also maybe have safety, health, and environment concern. And at the same time, what we can learn from Pak Ganjar basically how the issue regarding the metering, right? So especially on a discrepancy between the upstream and downstream, where we can minimize this discrepancy. But of course, at the same time, the discrepancy can be a loss, right? So we try to reduce this discrepancy by putting the system where we can have some a benefit between the producer and customer, as an end user of the gas. So the third presentation from Professor Bahman, he explained very clear to all of us about the hydrate management, what kind of risk, what kind of impact in terms of the gas production from upstream, where it can make some risk, some blockage, and then in the end can reduce the gas avails. So I think I really hope that all of the participants can enjoy this first event. As I shared to you earlier, we will have another event next year. Natural gas will become more and more a favorite, as predicted by a lot of consultants around the world, where the natural gas demand will increase over the years. And that is quite very interesting, especially for Indonesia, where infrastructure and in the same time, supply demand, the issue regarding the market, the rate is urgent. So thank you for all of the participants who asked the questions already, and then my grateful and thankful to our support, to the support from Universitas Indonesia, University of Indonesia, Professor Asep, Professor Sutrasno, Dr. Andi Nur Saman from Chemical Engineering Department, the Master of Gas Management Faculty of Engineering, Universitas Indonesia. So I wish all the best for all of you, and then don't forget to stay safe and healthy, and then follow the health protocol, wearing the mask, and then wash your hands, and then make a safe distance. And then I wish that this pandemic will disappear very soon, whenever the vaccine arrives to all of us. So again, thank you so much, and then enjoy your weekend. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you to Adrian for the hosting. I hope you all attendees have a great day after this. And as a moderator, I will give the greatest appreciation for participating. Thank you and have a wonderful day. Me, Randi Maulana Nasir, and my co-moderator, Mrs. Desti, and Rainy, sign it off. Please, to all participants, open your video because we have a photo session. To all participants.
Mungkin ada yang belum join. Probably there is not join.
To Miss. Okay. Who want to snapshot the photograph? Someone?
Miss Fanny not yet joined the webinar. Miss Fanny, all the organizing committee.
Maybe we wait about 5 minutes to wait to all participants. we begin, Mr. Ramzan?
Miss Fanny, could you on your studio, please?
Okay, let's turn on my video.
Mr. Benny? Mr. Benny. Yeah.
Yes, sir.
Oh yeah. Okay. So
Maybe we have, okay, we all complete, Mr. Ramzan?
yes.
Okay. Okay, everyone ready? 1, 2, 3. Cheese. Okay. Do someone get it or? Okay.
Again. Okay.
Thank you to all participants. Thank you. Have a pleasant night. Me, Randy Malanasir, and Mrs. Zumrah Destiani Ready. Sign off.
Thank you
Thank
very
you.
much for all of you. See you next.
Thank you. Thank you very much.
Thank you, Mr. Bahman.
Thank you.